Hey everyone. Hello everyone. I'm Jocelyn here for another technical stream. I know some of you were joining my streams yesterday. We got the chance to learn about Streamlit and also deploy our application on the web. And I'm sure we all had fun. And now we will be having another technical stream, but this time we will be focusing a little bit more on MongoDB, and we will also learn like many AI concepts that maybe sometimes when we hear them like for the first time, they might sound like a bit confusing, or perhaps when we see like articles online, we don't want to get like really into depth because they might be like a little bit messy. But don't worry, on this technical stream, we will be getting through the basics as we are all beginners, and we will also do like some advanced stuff in case you are a more like pro hacker and you have like more years of experience. So we are here for everyone. Let's see what we have in the chat. A nice dinosaur sticker. I love those. They're really nice. Hey, how are you doing? You might want to share with me what you all have learned in like a single sentence, like something that really stood out from this Global Hack Week, like your favorite moment from Global Hack Week. And I'll share your comments and we can talk a little bit more about it. Hey. Hey again. Yeah, so I'm kind of like a new coach here in Major League Hacking, and I'm really loving streaming tech content online. It's really fun to interact with the hacking community. I actually have participated in many, many hackathons. Like most of them at the beginning were national, like here in Mexico. But then I started participating in international hackathons, like mostly on the US, as they have like a lot of MLH hackathons almost every month, like plenty of them. Yeah, that's so cool. I actually like the music that I was playing for the intro session. It was really kind of low-fi music. And I was actually trying to figure it out if I could like add my own music into the stream to see if we can get it working. Let's see, we can put some background music while we code. That will be pretty fun. Let's see. I learned a lot in the Parquet workshop, which I found really interesting. It actually gave me an idea for my next project. Nice. And what project are you thinking of building? You can share it. You can share with us. Perfect. Let's see if we can get some music running. Let's see. Because it is actually nice to code and build projects with music. It really inspires us to work more. So I'll put the same that I was playing before. Let's see. Is the volume okay? I think it's okay. Like it is a bit low, but just enough to hear myself talking. Nice. Yeah, so well, now that everyone is here and the Twitch ad ended, let's get started with this first part for our MongoDB application. But first, let's see. You wanted to use MongoDB for the first time. That compares size, read write. Yeah, speed first use. Oh, so nice. That's nice. Yeah, I mean, today we're basically going to learn how to set up MongoDB from scratch, like signing into the platform, creating like your free cluster, and then just basically trying to set up all of the security and network access. And after that, we're going to learn about how to combine MongoDB vector database to build an AI application. And it is actually a project that I've been wanting to build for a while, which will be basically like a formulary for techies in the tech world. And when they fill out that formulary, their data will be uploaded into a vector database in MongoDB. And after that, we'll analyze like all of the responses from our participants, and they will give you a match. Like for example, I can be matched with other like two persons in the tech world, and I will get recommendations about why I was matched with that person specifically. And we will be having a lot of fun with that. And hopefully, for the next part of our stream, we will be able to visualize that information like in a nice graph. Oh, nice. Yeah, so today we will be basically diving into what is MongoDB and, building an awesome project. So let's get started. Perfect. Let me present this. So always don't forget to check in for our workshop. Let me send the link again in the chat in case you are new and you're just entering this technical stream. And checking in is always important, so you get your points for the weekend. So as I mentioned earlier, this technical stream is focused on MongoDB database, which is basically a non-relational database. This means that it is non-SQL. And MongoDB is actually an open source document-oriented database. It sounds kind of long. I know this bullet point is kind of long, but open source, well, it means that basically people can contribute to it, and documents, we will get to that later. And database, well, we all know that a database is where you basically store information. And something really nice about MongoDB is that it has a really fast integration with Python, which we will be using Python today. And it is also perfect to building AI projects because it has like additional features that you can integrate into your projects to work on them. Yeah, Python is really nice. So, if you were wondering what a relational database is, for example, SQL and my SQL, Well, that means that data is actually related. So you got your data stored in a table, and that table has columns and rows, and all of your information is basically related to each other. That's why it's called relational database. And you have like different columns to define information, and you have like rows that represent your actual information that is being stored. But for today, we will be learning about non-relational database, which is the case for MongoDB. And there are different types of non-relational databases. For example, the ones that store information in the form of key and value. Perhaps this might sound familiar for some of you who have worked with JSONs, which basically store information in the form of key and value. We also have graphs, columns, such as Cassandra, and the document type. So today we will be focusing on these ones in particular, which is the document one, because as I was mentioning on the first slide, MongoDB is a document-oriented database. So that's what we mean by saying document. And now let's see a fast example. MongoDB basically stores information in an object format. So for some of you who have already worked with object-oriented programming, might have like an idea of what I mean by storing information in an object format. But just in case, I'm giving you some context that by an object, we mean like, for example, we have a person, and that person has like different attributes such as like a name, an age, perhaps like a nationality, and so much more. And MongoDB, what it does is that it stores information as if like each piece of information is like a different object. So that's why they have this a specific field that says object ID, because every chunk of information is like a different object identified by MongoDB, and then we have like the different fields that are like the attributes of our object. And basically, instead of having like tables and columns and rows, in MongoDB information is stored in a different way. We have documents, which are basically like made up of key value pairs. As I mentioned earlier, key value pairs is pretty similar to what the JSON structure is. We will also be getting a little bit to see like some examples about this, so we know what do I mean by saying JSON format. And each document has collections, and yeah, so this is a nice like visual representation of how information is stored. So we have our database, which covers pretty much everything, and then a database can have like multiple collections. So I can have like, for example, my customers database, and then I can have like different collections depending on the I don't know, like geographical location of each of my customers. For example, I can have like Mexican customers, I can have like Indian customers, and like that. And inside each collection, we have documents, and each document is particularly an object. So you can see documents as a specific object, like a specific chunk of data that is being inserted into our MongoDB database. So what are we going to be building on this set of technical streams for MongoDB? So we're going to get an introduction to what vectors and embeddings are. Perhaps right now you might be wondering like, okay, how does MongoDB relate itself to AI? Well, we will be getting to that later on tonight. And we also want to know how to build an AI application from scratch using MongoDB. But first, and before we dive into these topics, we have to set up like our MongoDB database. We have to do like some initial configurations in there. We also have to make sure that we can connect to the MongoDB cluster. And after that, I will give you like a brief explanation about all these topics, and then we'll start building our AI application. Good. We got a question in here that's saying, if we're comparing it to SQL database, will a collection be like a table and a document as a row attribute? Yeah, that actually is a nice comparison. It makes a lot of sense. And if you read like some articles about the like a comparison between SQL and non-SQL databases, they actually refer to documents as being like the rows, and like, for example, the tables being like the collections. So yeah, it is kind of like the same, but not the same, because the information is actually accessed in a different way. But you can see it like that. That is totally correct. So let's start by going. I'll stop presenting, and let's start opening a new browser tab. And yeah, I'm a big fan of GitHub and the AutoCAD, if you've been wondering. And let's start by searching MongoDB. Yeah, let's go to MongoDB. And for some of you who have never used MongoDB before, let's start by creating a new account. In my case, I will start by signing in. Just that my screen is in Spanish, and I'm trying to read what it says in Spanish, but no, that's not correct. And you should be directed into a page that is similar to this one. And yeah, let me share this link with you so you can have it and access it directly. And you can access either by Google or GitHub. I think I have always accessed by Google. Actually, you know what? I'll start opening a private window so I can go through the process with all of you. Yeah, let's start with that. And we will be creating our free account to set up our initial cluster. And let me see if I can use another account. Well, I will write a random password, as I never use this email, so I'll just put 1, 2, 3, 8. What? A server error occurred? Oh, sign up. Let me sign up. So just go ahead and start creating your account. You know what? I'll actually access through my regular account, because I think I have already created plenty of accounts, like on the stream that we had yesterday. So I'll just open up the one that we had, and I'll try to recreate like the steps that you should be asked. I think it was this one. Let's see. And I think in my case, it would just log in like automatically. But in your case, you should get like on a screen where you will be asked to select any of the 3 like options. Always select the free option. So go ahead and select the free option. Then like just follow the formula that you will be that will be appear on your screen, and you should be good to go, and you should be directed into this screen. Always remember that if you have like questions or you are stuck somewhere, you can always ask me on the chat. Nice. So once we are here, you should have created a free cluster. And in case you haven't, you can click on this green button that says create, and you should be directed to a page like this. In my case, it is trying me to make me pay. But on your case, if it is your first time using MongoDB, you should have an option in here that is the free one. So just go ahead and click on the free one, and then you leave all of the information like as a default. So you leave AWS, and I think it's and Virginia, which is the default, and just go ahead and write a name. I recommend you leave it in the default, such as cluster 0, and yeah, then you go and click on create deployment. So basically in MongoDB, you create like these clusters, and the reason why it is trying to make me pay, that's because everything is hosted like on a live server. So of course, if you have something hosted on a server, it is spending energy, and therefore it is it is spending energy, so it has like a downside that you have to pay. But there are always free options. So now once we're here, we have several things to get through. So the first one is that we want to make sure that we can connect to our cluster from Python, and we will ping our cluster from a Python script just to verify that we can connect to it. And after that, we will set our cluster's network access, so we are able to actually access it from any location and any computer. And finally, we will give like a quick recap about what we learned inside MongoDB dashboard. So to get started, we're going to click on connect over here, and you should see a pop-up like this, and we will start to connect our application using drivers. And drivers are basically selecting like which code environment we want to be using. So you want to select Python, as we will be coding in Python the whole stream, and just leave the version as a default. Next, you should install the PyMongo module. In case you don't have it installed, you just copy this and paste it on your terminal. I will do that in a second. And then after that, we want to make sure we store this string into a safe space inside our code application, because it basically contains the credentials that we need to connect to our cluster. If you remember, when you were setting up your MongoDB cluster, it asked you to create like a username and a password. So always make sure to remember that password or store it somewhere. And yeah, so we can get to it later. Yep, I can zoom in. I think it is good like that. Yep. So let's get started with we'll make sure. Let's start opening a new VS Code tab. Let's see, here we go. So go ahead and open a new VS Code tab. In case you don't have VS Code installed, you can always open a GitHub code space from your code repository and do that online. In my case, I will be using VS Code this time. So let's go ahead and create a new repository first. So let's head over to GitHub. Yeah, let's head over to GitHub. And as we want to create a new repository, I will zoom in here too. I think that's okay. Let's create a new repository myself, and we will call it AI match MongoDB MLH. And then I will make that public, and I'll share with you in a second in case you want to be in the same page as I am. And you can also fork this repo or clone it in case you want to work with it. So as a description, I will actually paste the no, I don't have a. Yep, I will paste this global hack week MongoDB. I will paste this description. It will be public, and I will add a README file so I can customize for you later. And as a git ignore template, we will add Python as a default license. I always like to choose MIT license, but go ahead and choose whatever you want, and click on create repository. Nice. So I will share this link with you in case you want to clone the repo. I will also be adding commits to the repo, doing the live stream in case you want to fetch and actually like see the refresh version. Yep, so now let's go ahead and clone this. You're going to click on code, and then you're going to copy paste this link, and then you're going to go ahead and go to the tab that you had opened on VS Code, and you will click over here where it says clone git repository, and you will paste the link from my repo in there, and you will click enter. And after that, you will select a default, directory. I will choose downloads, but you can choose whatever you wish. Select the repository destination, and now I will click open. And this will basically open my repo over here, and now I can start contributing to it and making all of the updates over there. Perfect. So during this live stream, we will also be using Streamlit to actually make a front end for our AI application, and to have like somewhere where we can actually input information for our MongoDB database. So firstly, as I mentioned, our first step is to create a Python script where we will be pinging our cluster in MongoDB. So go ahead and create the mongo.py file where we will be accessing our MongoDB cluster. So if we go back to the MongoDB dashboard, we first have to install a PyMongo. So let's go ahead and copy this to our code. Let's open up any terminal. Oh, what's this? And let's paste what it said. You can also create a VNB in case you don't want to have it like all in a global session as I have it. That is not like one of the best practices, but yeah. And while it is installing, we're going to go over here, and we're going to toggle this button that says view full code sample, and we will copy paste this, and we will go back to our script, and we're going to paste this over here. And this is just an example script that MongoDB gives us, that it's to make sure that we are like connecting to our cluster. So this is another question. I normally use JavaScript. Do I need to install Python? If you want to be following up with this stream, yeah, you might want to install Python. And I recommend you opening up my repo in a code space, just like this. You go ahead and code, and then code spaces, and then you're going to click on create code space on main. So it will actually like open up everything that you need to have installed over there, and you no need to do any like additional config. So yeah, the reason why I said that we will not be using JavaScript is because later on we will be building our application, and we will be using Streamlit, which basically uses Python. So yeah, let's see. So everything is installed, and now something that we want to make sure over here is to add our actual password. And if I were to just like add my password over here, let's see what happens. I think it was CTE123, and let's go ahead and run this. So go ahead and change your username and your password, and if you go and just like copy paste this, it should bring you like your own configurations. The only thing that you have to add is a password. I believe in my case it's saying that I'm having like authentication issues. That might be because I have a wrong password. Let me check again. ABCDE123. Let's see, cluster xy9q0. Oh, yep, I have another cluster URL. Let me go and change that. If you're getting this same error, that is always the meaning that you basically have like a mistake on your string URL. In my case, I have a wrong URL cluster, and this is a URL cluster, so I'll just go ahead and change it for the actual one that I have. So let me run it again. Hey everyone, first time here. Nice to meet you. We are building an AI application using MongoDB, and we are just getting started, so you might want to hop in. Nice. So now I'm getting the message, ping your deployment, you successfully connected to MongoDB. So with this example script that we just ran from the MongoDB dashboard, that means that I am able to connect to my cluster successfully, and now we can actually like start building our application from that. But before we start creating like all of the things that we will need, I will go back to MongoDB and just give you like a brief showcase on how information is stored. So you can go ahead and click on done, and then we will click on browse collections to see how info is being stored. And we can see this one is one that I have, but everyone should have this one, which is basically the example dataset that MongoDB gives you. Let's go ahead and click on one. And right now, as we saw on the slides earlier, we can see that sample MFLIX is our database, and then inside our database we have the different, collections. Yeah, we have the different collections such as comments, embedded movies, movie sessions, theaters, and so on. And in my case, I selected the comments collection, and as we can see, we have like different objects. So this is an object called Mercedes Tyler. Then this is another object called John Bishop, and each object has an object ID and has like the different fields that are to be stored. And you can also like select the different data types that will be stored. Something that I really like about MongoDB is that you can just basically like upload pictures or videos, and when you actually try to fetch them, it is actually much more easier than on a regular relational database. So it's pretty nice. We also have more things in here, such as indexes. So we will not be getting a lot into depth in this. We will actually create one later on, but indexes just basically make our search so much faster. So let's imagine that we have like tons of information over here. Like in my comments, I have a lot of objects, and I want to make a query, and I want to make it go like really, really fast. So to make my query more efficient, we use indexes in order to index our search, so it doesn't take like a long time to actually show up the results. So yeah, that is basically what was on the slides. And now the second step is to set up our network access for our cluster. So let's go ahead and see on this tool menu, and let's click on network access. So what we basically have in here, and what you should have in here, is your IP address with another one. And this basically means that you are the only person that can access like that IP address, and you're the only person that can actually like make requests to your database. So in case you want to share your AI app with someone, like after we finish the stream, you won't be able to do that because you only have like your IP over here, so they won't be able to connect to your database. So in order to change that, you're going to click on edit, and then you will I will delete this. I will add IP no, that's not true. I'll click on confirm. Well, I already changed it, but you should be receiving, like, if you click on edit, you should see like a white button over here that says allow access from anywhere. You will click on that, and then that will basically make your IP address like a lot of zeros. And in case you're not seeing that white button over here, then just go ahead and click and type like zeros slash zero, and you should be good. You will click on confirm, and the status will be like pending. And once it finishes loading, you should get like the active status over here, and that should mean that you are like good to go. So remember that if you have any questions or you're stuck somewhere, you can always send a message in the chat, and I will answer promptly. Nice. So once we finish setting up the IP address to be like whole zeros, that means that we are good to go and that you should be able to access your application from anywhere. After doing this, we are going to see how to change the password for your cluster. Because, for example, earlier I was getting an authentication error, which means that either the password, username, or cluster URL is wrong. So in case you forget your password or you want to change it, we're going to go ahead and click on database access. And from here, we can basically see the users that we have in our database. So in my case, it is only me, and I have access like to basically everything. So I can do like anything on the database. And you're going to click on edit, and then you can click on here, edit password. You type like your new password, you copy it, and then you click on save, update user, I'm sorry. So you click on update user, and it should take a while. Most of the time it takes like 1 or 2 minutes to finish like updating. Let me actually change this so you can see how it appears. So 1, 2, 3, 4, 5, A, B, C. And then I'll click on update user. And you should be seeing like this blue message over here saying we are deploying your changes. It takes a while, and after the pop-up is gone, that means that you have updated your user correctly and that you can now make like requests. So now if I go back to my Mongo script that I had earlier and I try to run this again, I will get an authentication error because I changed the password. Or no? Perhaps I'm pinging another deployment. But well, let me change the password over here and try again to see if I'm pinging a wrong deployment. Let's see. Yeah, so I think I'm pinging another deployment. So let me go check. As I'm getting authentication error, that means that either my username, password, or the cluster URL is wrong. So let me go ahead, go to clusters, click on connect to see what my URL is. I'm going down, and I will copy this cluster URL. I will click on done, then return over here and paste it in here. And now let's try again. See, so now it is good to go. It says ping your deployment, you successfully connected to MongoDB. Nice. So that means that we are good to go. Perfect. So now we're going to start building the front end of our application. And to do that, we're going to use Streamlit. So Streamlit is basically a tool that will help us build, a front end for our application using completely Python. So let's just go quickly to Streamlit's documentation. This one. Let's go to Whoa, this is actually not it. That is a Streamlit Cloud. That is where we will be deploying our application. So let's go to Streamlit Docs. We're seeing a message, another question. What did I miss? For now, we need to create an account. Yep, that you are correct. And I will I also shared in the chat the GitHub repo where I'm currently working. So in case you get lost, you can always go into there. Actually, let me update the repo so you can see the connection example. But I will delete the URI, as it will, like, I will be getting a GitHub error if I upload the credential. So I will just leave it like URI, and I will add a comment, add your string URI from MongoDB dashboard. Yep, and that's it. So let me update this to you. Ping connection to Mongo. So now you can actually see like the code example to make it work. Good. So that is updated. So let's go back to Streamlit. So we're going to be using this super helpful tool. I'm not going to get a lot into depth on what is a Streamlit, as we had that workshop yesterday, but I will give you the basics just to get started. So all you need to do is install Streamlit, running pip install Streamlit. So let's go ahead and install this. I will share this link with you on the chat so you can follow the same steps that I'm doing. And in comparison to other frameworks, Streamlit is really fast to set up. You just have to install the module, and that is all you need. So you just have to run this command on our terminal. So let's go ahead and run this. Why can't I see the bottom of this? I'm sorry. Many screens in here. So let's create a terminal. Let's go ahead and pip install Streamlit. It will start installing. In my case, I already have it installed, so it's just showing me like, oh, requirement already satisfied. But in your case, it should be like installing the actual module. So after that, we're going to run Streamlit run to make a Streamlit hello to make sure that we have a Streamlit installed. So we're just running Streamlit hello. And this should basically open up an example application on our browser. And if we get to that step, that means that we have Streamlit installed and we are ready to build our application. So sometimes it takes a while, but it should be really fast in your case. And yeah, that is all we need to install Streamlit. And now our example application actually popped up. So this is the example that pops up when we run Streamlit hello. And we can see like all of the features that we can create, such as like animations. We can also plot like different elements. It is actually, I like to describe Streamlit like a nice Jupyter notebook where you can basically visualize all of your data in a single place, and you can actually like host your application on the web and you can share it with anyone. Streamlit is actually a really helpful tool when building, like hackathon projects, especially because in a hackathon you want to deploy your application like quickly and you want it to look nice, and perhaps you don't want to spend like a lot of time in the front end. If that is your case, then Streamlit is your go-to module that you want to use from Python. Good. So now that we have Streamlit installed, we can go ahead and start building the front end of our application. So let's go ahead and return to our code. Good. So I will create another file that will be called home.py, and that will be basically the root for my application. You can go ahead and name it. You can put this, whatever name you want. This will appear in the application. You will see later where the title of our script will be placed. So we will start by importing Streamlit. So import Streamlit. as st. It is always st. Well, not always. You can choose whatever, but it is just like the basic notation. For example, when you import NumPy, you refer to it as np. So we will try to stick to that format too. So to start building our app in Streamlit is really quickly to start like setting this up. So for example, if we want to write a title, what we want to do is just refer to our Streamlit instance as st, and then we're going to call like all of the different method options that we have. In our case, we will start typing title because we want to set up a nice title for our application. And inside the parentheses, you just want to write the double quotes and just basically type whatever you want. In my case, I will basically call it like matching app for techies. Nice. And after that, I will place a divider so we don't like we have like a nice separation between our like title and between all of our content. So to make a divider, we call again st and then write literally divider. And then after that, I want to make like I want to write a text where I will basically lay out the instructions for the people that enter my app, actually know what it is about, and just like basic concepts about what my application will do. So to write something on your app, you just literally type write, and then inside the parentheses, you're going to type like welcome to my app, fill the form to get started. Nice. And after that, we will create we will place another divider to separate the introduction from like our formulary, and we will include a subheader for our form. So I'm going to write add a subheader, and as you might be wondering, to add a subheader, you just type subheader. It's really direct, actually. You can also go ahead and see a Streamlit's documentation in case you want to add like more elements. For my case, I would just add this, and if we have more time, we can add like more elements afterwards. So I will click fill the form to get matched. Nice. So a little bit of context for those of you who joined a little bit behind. We are basically building an AI application using MongoDB, and in my application, I will show a formulary for people to like answer, and after I hit send, I will be basically giving that person recommendations on the person that person has like a potential match, like a matching app, but for people who are like into technology. So the questions that we will be like writing will be about like technology questions, like for techies. Nice. So let's run our application. And to run our application, it is very simple. Just let my terminal stop the other instance. It is not quitting. I will create a new terminal. Let's see. Nice. So to run our application, we're going to use the Streamlit command, run, and then the name of our script. So the name of my script is home.py, so I will type home.py. But in case you have a different name where you place your Streamlit application, you want to type that name. So I will run this, and it will open up another browser window with my application. Good. So now it is loading, and as we can see, we have our title, we have our two dividers, we have our text, and our subheader. So now I will create another page that we will use later on. So let's go back to our code, and I will push this into GitHub in case you want to see it. So UI changes on home. in case you want to follow up. Good. Remember that if you get stuck somewhere, you can always ask me on the chat if you have any questions or just random comments. You can go ahead and type them. Good. So now we're going to go ahead and create our pages. So you know how sometimes like applications or web pages have like different sections that you can navigate through? So to create that in Streamlit, it is actually pretty easy to do that. So we're going to create a folder that will strictly be called pages. So we want to call our folder pages in order for Streamlit to actually recognize it. And inside this folder, we can go ahead and add as many scripts as we want, and each different an individual script will be a new page in our application. So for example, if I go ahead and type, for example, visualization.py, this will basically create a new page in my script. So if I go back, now I can see that my application has been updated, and I see like my two sections, like my home and my visualization script. But in here, I don't have anything, so it should just be empty, an empty page. So I'll just add a normal title, so we actually can see something. So st.title, this is a title. Perfect. So if I go back, it is already updated. This is a title. Nice. Perfect. So that is it for this. And we also want to have another folder. And in that folder, we will be basically storing like our sensitive information. So for example, when we were setting up our MongoDB cluster, if you remember, we had a string URI with all of our important credentials. So those credentials, we don't want them to be uploaded to GitHub, and we don't want them to be like in our main script. So Streamlit has a feature called secrets, where you actually get to store like that sensitive information in this file. And that file is basically hidden from when you deploy your application. So all of the credentials are secure. So to do that, we're going to create a new folder that will be strictly called dot, like just a dot, and then Streamlit. So it is a new folder called dot Streamlit. And inside this folder, which is basically a configuration folder for Streamlit, we're going to create a file that will strictly be called secrets. It has to be called secrets. And then dot, and this is the extension. Nice. So in here, we will be basically storing all of our keys in the form of variables. So for example, if we have like a key, for example, key equals to new key, and we will be storing information just like this. And in a while, I will show you how to access this information over here. But firstly, we want to add this folder into our gitignore file. Why? Because we don't want to be pushing this into GitHub. So to do that, we can just grab a new line on our gitignore file, and we will be typing basically the directory that we want to ignore. So in our case, we want to ignore the .streamlit directory. So I will just ignore all of the files that are inside this directory. A little bit of context in case you don't know what a gitignore file is. As the name says, it is called gitignore. So you basically want to ignore all of the files that are inside that file. Yeah. So we are ignoring the .streamlit directory. I will push this into GitHub. So added secrets. Nice. Good. So after this, we are now going to start building our application. Yeah, we are officially ready to go. We already know some of the basics about how to set up like our cluster in MongoDB. We already connected to it, and we already built like our front end. Well, at least the initial steps. And now we will be completing the front end to add like the fields of our formulary, and then we will actually be filling on with some of the backend functions. So to get started, after adding the subheader, we want to create like our formulary. So to create our formulary, it is pretty easy. So we're going to be calling Streamlit again, and we're going to be typing text input. Why? Because we will be basically asking like questions to our users. So for this section, if you have any question recommendation that you will ask like a tech person for you to know them better, you can type them in the chat and I will add them into our formulary. But in the meanwhile, I will just type like, for example, what is your name? Then I will be copy pasting this over all. Let's see, we will also be asking like, what is your favorite programming language? Well, no, what are your programming languages? Text input. Perhaps what is your favorite framework? Dot text input. What is your favorite tech conference or blog post? I'm just adding like random questions that I would ask like someone at a normal hackathon. And this is actually like a really nice icebreaker when you go ahead and meet new people. Like, what else? What is your... Oh, no, perhaps have you contributed to open source? Source and name projects. What else? I'll add a last one. Input. I am out of ideas. What is your favorite tech celebrity? Okay, that's a good one. What is your favorite tech celebrity? And let's add a final one that it is, what is your favorite code editor? Favorite code editor. Nice. And now, if we go ahead and refresh our Streamlit page, we will be basically seeing like all of the sections that we have. Good. So now we have our different fields over here for the questions for our users to fill out. The one, what is your name, programming language, favorite framework, and so on. And we're missing to add a button over here. So let's go back. And to insert a button, it is just as easy as typing this. And this will basically like just like pop up a button. This is a button. If we go back and refresh, we will be seeing the button over here. But if we click it, it doesn't like pops up anything because we have like no function associated with it. And it is pretty nice that it has like the hover color and everything. That I just love that I don't have to configure that for myself. Before I met Streamlit, I was actually not a very fan of any like framework because I'm not a big fan of front end. So yeah. So to make this button actually, do something when we click it, we're going to just add an if conditional before it. And once we do that, this will basically tell us that if the state of our button is true, then we want to do something. In our case, it will basically be like generate potential matches for my tech form. And in case this happens, then we want to output a success message. So we're just going to type success, and we're going to say, Jay, you have been matched. Yeah, I actually tried that for a while, but I was just like in my phase where I was learning like a lot of backend things. So I just left like front end for a long while. I actually started with Flutter, and after that, I learned a little bit about Bootstrap, Vue.js, and I was getting into like Mern stack. But then I was just like, okay, I don't want to continue learning front end. But yeah, I totally I respect like 100% those hackers who are actually able to build like a website using like any framework like really quickly. That is just impressive. Like I just get a really hard time trying to align everything and then to make it responsive, and I just give myself up when I'm trying to do that. So yeah. Now, once we click the button, we should get a success message. And in case the person has not completed the form, then we're going to do else, and we're going to add a warning message that basically says, hey, something went wrong. Oh yeah, I'm missing the 2 dots. Nice. So now if we go back to our Streamlit and refresh it, once we click the button, we should be getting the success message, and yeah, you have been matched. And eventually this should output like all of our elements that we have for doing the match in our Streamlit. So I'll go ahead and push these changes into our repo. So added button to handle responses. Good. Perfect. So now that we are done with that, we are moving on to the next section where we will be basically setting up a vector database in MongoDB. We will do that on the MongoDB dashboard. And once we set that up, we will be moving on to the slides again. So we get a nice introduction to what are vectors, embeddings, cosine similarity, a lot of AI concepts. And once we understand them, we will be moving back to our Streamlit script, and we will be adding some additional backend functions for doing 3 things. The first one will be basically connecting to our cluster in MongoDB. The second one will be basically storing like all of our responses in a document format. And after that, the third step will be basically uploading them into our MongoDB cluster. So yeah, let's get back to it and return to our MongoDB dashboard. So if you go ahead and click on clusters, and you were already working on your cluster and actually pinged the cluster successfully, like in the Python script that we built earlier, you should be seeing like some activity that you were basically like interacting with it. So to start creating our vector database, it is pretty straightforward. So we're going to go ahead and click on Browse Collections. And you want to go ahead and click on Create Database. Wait, we have a question. What is Compass? It installed when I downloaded Mongo and I saw Cecilia open it briefly. Yeah, so Compass is basically like the application that MongoDB has for using Mongo on your computer, like the application, So it is basically the same. You can go ahead and use Compass if you want to. In my case, right now, I am doing it from the web browser. Everyone can do that, and there's no need to install anything. So yeah, it is the same. I think the dashboard is a little bit different, but it is basically the same. And it is sometimes it is actually better because it runs faster when you are if you have like a powerful computer. It is better to have Compass installed. So for database name, we're going to call it let's see, techies, because we are storing like techies responses. And we're going to start creating an initial collection that will be called responses. Nice. So database name and collection name. We're going to go ahead and click on create. And this should create our database and our collection called responses. Good. So now we're going to go ahead and create a search index that will be basically our vector database. But before we go into doing that, I think it will be better for us if we all understand what a vector is and why do we want to be creating that specific type of database in our cluster. So let's go back to the presentation real quick and move on into, so I was with this one. Nice. Yeah, so we will be basically creating a vector database, which is a specific type of database that you can actually create from MongoDB. But there are other ones online, such as Pinecone. That one specifically is just for a vector database. And we all, I believe, most of us have already heard like the word vector, perhaps in physics. At least in programming, it's basically the same. It is, but we like to refer to it, like as a numerical representation. So it is just like a big number, like that stores like different pieces of information. So in this image, for example, a vector can be like the chicken, then another vector can be like a banana, then another vector can be an apple. In our case, if we are storing information into our database, so perhaps the techie number 1 is going to be a vector, and then the techie number 2 is going to be another vector, and like that. Something nice about vectors is that, for example, let's imagine that we are trying to make like a query in our database, and we basically want to bring like all of the animals that we have in our database. And for example, I go ahead and enter my search bar for my application and type, as we have an example here, and type cat. So our regular database will basically bring me the responses that are like the same as for the spelling, like cat has a C and an A, so it will probably return me car. But I was actually searching for cats, so car has nothing to do with cat because car is like something totally different. But you can see that the words are the same. So for vector databases, the benefit from them is that you are performing a semantic search. So you are not searching by spelling or by similarities in the word as for its structure, but rather you are searching for the actual meaning of the word. So as an example, if I search dog, I should be getting responses such as puppy or, things related to dog and the actual meaning. And if you can see, dog and puppy are not like, don't have like a similarity in how they are written, but they have a similarity in the meaning of the words. So it is very helpful. For example, when you try to store information and you want to retrieve it, you want to retrieve it by its meaning and not by its like actual spelling on how it is written. Perfect. So now that we understand the concept of and the purpose of a vector database, we're going to go ahead and understand what are embeddings. So probably you have heard, if you have used some of OpenAI models or ChatGPT, that some of the models are called like embedding something or embedding like and some random numbers. So embeddings are like a fundamental thing in AI and machine learning. Why? Because embedding, what they do is just basically transform like a piece of text or an image or a document or anything that you will like to call like information, and then they transform that piece of information into a number. So for example, my cat will be 0.185. I'm just saying random numbers. And for example, the image of my puppy will be another set of random numbers. So if we go ahead and see this visual representation over here, we have a text. It is a random text. And then we process it using an embedding model. And then that embedding model basically transforms each of the elements in my text into a numerical representation. And each of these numerical representation is basically a vector. So now it is starting to make a little bit more sense that the relation between embeddings and vectors is that embeddings basically convert information into vectors using like specific algorithms or models. There are like a lot of different models that you can use that replace, like for example, this gray box over here, and we will be using like many more. Yeah, this is actually really helpful, and I like to be saying like all of these things because sometimes like when we see like these concepts, we are not very familiar about like what we are talking about. So yeah. In here we have like other examples such as like a sentence, and then that sentence we pass it on into an embedding model, and then that sentence is basically transformed into numbers that are like the representation. So the sentence transformed is basically these sets of numbers. And once we have like the numbers of our different vectors, you can actually go ahead and plot that in a two-dimensional space. So now you can actually get the relation between like their different sentences and like where are they located. Yeah, so this is basically what we are doing right now. We are building our AI app, and yeah, it would have been better to actually present this in the beginning. But now what we're going to do is that we are going to use semantic search to build our recommendation system. We already built the front end of our application, and now we will be actually going into depth into this. We are also going to set up the vector database in MongoDB. After that, we're going to use a Hugging Face model to transform our sentences into numbers. And then we're going to host our project in Streamlit. So depending on how fast we advance, we're going to continue to see how fast we can get there. So let's go ahead and return to our MongoDB cluster. And we are going to convert this database into a vector database. So to do that, we want to go into indexes over here, and we are going to click on create index. Nope, I'm sorry, I was wrong. It is search indexes. Yep, search indexes. And as we can see, MongoDB already has like is giving us like different recommendations on what to do in here. So we will be basically going with this option that says Atlas Vector Search and says build semantic search and AI powered applications. So we already know that what a vector is. We already know that basically the information that will be stored in there will be converted into an embedding. And after that, we will be able to perform semantic search because, as I mentioned before, we want to search by meaning rather than by, the actual spelling of the word. So yeah, that is semantic search. So go ahead and click on create search index, and we're going to click on vector search. This is actually really big. Yeah, so vector search, then go down. You can leave the default index name, and then go ahead and select the collection that we created, which is the one called techies responses, and then responses, which is our collection. And then in here, you're going to select JSON editor. So going back, vector search, leave the default name, select our collection, and then JSON editor. Click on next. And you should be seeing this like JSON snippet, and we will go ahead and change some things over here. So in here, we want to specify that we will be storing in the form of embeddings. So we will place in here embedding. Then in similarity, we will be using something called cosine similarity. I will explain this later when we are coding, but this is just basically to tell our MongoDB vector database that we want to find the similarity between two objects. So the two objects will be like, for example, techie number 1 and techie number 2. And a number of dimensions, we're just going to place a holder number, because in here, this is basically specifying like how long my embedding will be. So this is a really specific number depending on the model that we will be using. I actually don't know this by memory, so I will search it later on the stream and we will change this number to be the actual one. I think it is 768, but if I am wrong, we will change it later. Good, so once we have this, we are going to click on next, and we're going to click on create vector search index. Good, so we have another question. Will there be a swag drop too? For this stream, we won't be having a swag drop, but perhaps in the one that we have later on, we will have one, so stay tuned. And always remember that you can earn swag by checking into the streams, and checking into 5 or more streams will earn you bonus swag. So yeah, now you should be seeing that you are all set, and now our search index is basically created. So we're going to go ahead and click on close. And now we are seeing that we have a vector search of type embedding in our techies responses database. Nice. So once we have that, we basically have set up our techies responses to be a vector database, and we can now actually query it and search by vectors. So let's go back to our VS Code where we had our script. Yeah, here we go. So now what we want to do is that we want to connect to our Mongo cluster. We have done this earlier in this script, basically by creating a ping to our deployment. But now we want to make it a little bit more formal, so we will be adding it into our Streamlit. So firstly, what we want to do, we want to import the PyMongo model. So PyMongo, no, I'm sorry, it is from PyMongo. From PyMongo, import Mongo client. Good. And then we also want to start creating like the different variables into our secrets file, because we want to store like the sensitive information over here. So I will erase this, and in your secrets file, you will start typing like your Mongo information. So it will be user equals then information, then password equals information, and then it will be Mongo. No, I will call it URI, and it will be another piece of information. How long will this stream be? I have classes to 10. Can we access the stream? Yeah, of course. So this stream is ending in approx 40 minutes. Then we will have a mini game that will last an hour, and then like 2 hours from now we will have the part two for the Mongo DB workshop. So this is a two part technical stream, and remember that you can always watch the replays on YouTube. In case you want to see the schedule, let me share that with you. I think I actually have it here. There we go. So I think I was having some connection issues, but let me post the schedule on the chat. There we go. So you can actually see like what we have after this stream. So let's continue filling out our credentials. So in my case, this is my username. I actually don't mind sharing this with you because I created this account specifically for the stream. So it doesn't matter. Like this is nothing specific, and I will paste my cluster URL. Nice. So now we have all of the sensitive components into our secrets file. So let's go back to our home script, and we are going to access these variables from our secrets file into our home. So to do that, we're basically going to do user equal st.secrets, and then we want to type I don't remember the name of those, but you want to type that. And then in here, you're going to add the name of the variable that you have over here. So in my case, it is user. So I will do user. And then after that, we have password equals to st.secrets. And this will be password. And then after that, we have the URI, which is basically st.secrets, and then we have URI. So I'm going to call these different because we are going to construct our URI from there. So I'm going to call it URI. Nice. So I am back. My internet disconnected for a second, but now we are good to go. Let me share a screen again. Perfect. Nice. So let's continue. So I was telling you that we have to go back to our cluster and copy paste the link that we had when we were clicking on connect. So connect, drivers, we have done this before, so you should be pretty familiarized with this. We're going to copy this URI, and then we are going to go back to our script. Here we go, and we're going to paste it in here. So from here, we basically want to replace our username, our password, and our URL with the information that we have from our secrets file. So to do that, we want to format this sentence because we will be adding the variables inside of here. So I'm going to delete my username over here, and I'm going to do the brackets and start writing username. I'll do the same. Oh, it is actually called user. I'm sorry. So for this one, it will be password. I will change this. This is user. And then for the URL, this will be URL. Nice. So you should be seeing something similar like this. I will also push this into GitHub, so you can just follow the same format and just add like your own credentials for your own database on the secrets file. Good. So after that, we want to make our connection with MongoDB, and to do that, we already know that we have like pinged our deployment, but we now want to create like the MongoDB client. So to do that, we're going to create a variable called client, which is the one that we will be calling like over our script. And we will use the Mongo client instance, and we will pass on the URI. So we're basically doing this so we are authenticating into Mongo client and saying like, hey Mongo, these are my credentials, like, are we connected or not? After that, we want to select the database that we will be using. So I will call the variable DB, and we will be basically using the client that we created earlier, and we will be calling this the name of my database. I actually don't remember the name, so I will go back to it in a second. And then we are going to also create a variable for the collection that we will be using. We're also going to call the client, and we're going to type in double quotes and then the names. So let me go back and check the names that I had. Browse collections. So it's techies responses and responses. So my database is called techies responses, and my collection is called responses. So don't worry if you haven't created like the database or collection. In case this collection or database doesn't exist in your MongoDB dashboard, the Mongo this will actually create it by itself. So it doesn't matter if you made like a spelling mistake or something, it is totally fine. So I will go ahead and push this into GitHub so you can actually see what's going on in case you just want to copy paste what we are doing. Nice. So after creating our connection with MongoDB, now we want to get into the AI things that I was mentioning earlier. So first of all, what we want to do, let me go back to the formulary. We will be basically receiving like a lot of responses from this file. So we have many responses, which means that those responses will be written in like a string format. So we want to change that format and convert our responses into numbers. So if we remember a little bit from the slides, to make that process, we want to convert our responses into embeddings. And to do that, we will be using an tokenizer model from Hugging Face. I will get to it in a second. Hold on. And after that, we will be basically converting all of this information into vectors that we can now store in our MongoDB database. So I mentioned some concepts in here, such as Hugging Face. I also mentioned embedding model, and I also mentioned tokenizer. So let's go ahead and explain that real quick. So Hugging Face is basically a page where you can find like open source models for LLMs and AI things and projects that you want to use. It is really nice because you can actually explore like all of the open source models that are there for you to use. Some of them require you to have like a key with like an access key for like most APIs. But in this stream, we will be using an open source model from Bird, which doesn't require you to have like any kind of access key or any kind of like initial setup. So let's go ahead and search for Bird. Let's see if it appears. Nice. So as we can see, this is actually part of one of the Hugging Face models. And we can have the definition over here. Where is it? Bird. Here we have it. Bird, which stands for bidirectional coder representation from transformers. It is a long text. We're not going to get into all of the technical details that are on this page, but we do want to know that we will be using this embedding model, which is free and which basically will allow us to convert our text into embeddings, and then it will allow us to create that into something understandable for our vector database. So let's go ahead and go back. Let's see, we have if I prepared a slide for that. Yep. So I actually prepared a slide for what BERT is. This is the long definition that we have. And I also mentioned tokens. So tokens are basically like when you divide text into smaller units. So for example, for this sentence, I like tacos and to dance, the tokenizer, or like each individual token, will be like parsing the information into individual words. Like for example, I like, and then, tacos and to dance. So what BERT will be helping us today is to create like this tokenization of our sentences. So for example, in here on what are your programming languages? So I can write like I like to code in Java and Dart. So our tokenizer will basically divide like Dart and Java code, like each section of this sentence will be divided into different tokens, and then each individual token will be converted into a numerical representation, which will be our embedding. So let's go ahead and start coding that up. I already posted the most updated things into the repo in case you want to visit it. So let's continue. And firstly, we want to import some libraries that we will be using for this technical stream. Let me just look for the names real quick. Yep. So we will be using Torch. Torch will actually take a little bit of while to install. So if you can help me out and start installing that with pip install Torch. It will take a while, and in my case it is already satisfied, but in your case it should start like installing. So install Torch, which is the one that usually takes a little bit longer. So in case you don't want, perhaps we won't use it, but let's just import it for a while. So now we want to import all of the dependencies that we will be using from BERT. So we're going to install the transformers, and we want to import several things, such as the BERT tokenizer, which is the tool that will basically help us like divide our sentences into individual like words for our embedding model to understand. And then we're going to import the BERT model, which will allow us to convert this into text embeddings. I don't know why it is not like getting them. There we go. So now they are in green, which means that they are good to go. You can also go ahead and install transformers just directly, like pip install transformers. There we go. It will start installing, and then we also, yep, I already have it installed, so that's why it's throwing me errors, but in your case it should be, oh, I actually typed it wrong, but you can install it just by running pip install transformers. I will write the commands in here for the GitHub. And yep. Then we also want to import NumPy, as it will basically be helpful to be storing like the arrays or the vectors that we will be working on later. Nice. So I think we have all the dependencies that we need, and now we are going to create a function that will basically allow us to convert our text responses into embeddings. So to do that, let's go ahead and start typing below our Mongo connection, and we're going to call this function generate embeddings. And this function will basically like receive a text, and that text will be like all of the responses that we have in here. Hold on, let me fix this. It says st-secret has no key password. Oh, as you can see, I have a mistake in there. It says password. So let me go ahead and fix that real quick. Password, it is correctly in here, so maybe I mistyped over here. Password, huh? That is, oh, there we go. Password. Nice. So let's go back. Oh yeah, that's because I didn't finish the function. Let's first finish the function, and I will just return. Yep, let's see if I don't get an error. Let's continue. So it will take a while to load sometimes, because this is basically installing the dependencies that we imported over here. So in a while, I should be seeing like a progress bar in my terminal where everything is like being installed. But while that is going on, let's continue by creating our function. So we basically, in here, we want to convert all of the text from our formulary into embeddings. So to do that, we want to create a variable called inputs. And those inputs will be basically all of the responses to my form. So it will be like my favorite programming languages, my name. It will also include like my favorite tech conferences, and so on. So it will contain like all of the information from our formulary. So to do that, we basically want to use the tokenizer from BERT. And by having that tokenizer, that actually we have to create it before. I thought I done that. So in here, we're going to create our tokenizer. And in here, we're going to use the dependencies that we already imported, that are BERT tokenizer. And this will basically going to use, we're going to call the model that we want to use. So it will be from pre-trained. And the model that we will be using today is called BERT base, I think is on case. Let me actually search that. I'm not sure the name. BERT base on case model. I just want to make sure that the name is correct. Let's see. BERT base on case. Yep, so is the model that we will be using is this one. I will be sharing this in the chat in case you want to take a look into the documentation. And you can actually see some examples over here. Yeah, so it's called BERT based on case. So let's grab this for our script. bird based on case. I think I had a really nice idea of what the name was. So now we have our tokenizer that will help us divide the text into words. Then we are also going to import our model using bird model. And we're also going to call it using from pre-trained. And we're going to use bird based on case 2. Nice. So we already have our tokenizer and our model, and now we can actually call it from here. So it will be the tokenizer will receive, of course, the text from our formulary. It will also return tensor. I think I am misspelling it. Return tensor. And I'm not going to get a lot into depth about what this means, but basically to use torch, PyTorch, it basically stores information into tensors, and basically a tensor array is the same, almost the same as a NumPy array. It's just like in the form of tensors, and this like tensor array, which sounds like really complex, it just basically means that you can run either on GPU or CPU. So there's not much into it. And this will be PT, which is basically PyTorch. Then we also want to make sure that the padding of the text that we will be inserting into our tokenizer, it is activated, because we want all of the text to be like the same format. And we also want to activate the truncation, because in case our text responses like exceed the actual limit for the model, then my tokenizer will just truncate like that information. So that is just basically what it means. And then we want to pass like all of this information from my tokenizer into my output variable. And we want to use the model variable that we created earlier, which contains my bird model, which is bird based on case. And we want to pass on like the inputs. So after doing that, we want to now generate our embeddings. No, I'll call it embedding. So to create our embedding, we're going to take on the output that our model from bird gave me, and we're going to use the last information that it has. So to do that, last input hidden. I'm going to search this later because I'm not sure if that is a function that we have to use. And then we're basically going to obtain the mean, which is basically like the average. And we're going to tell that the dimension will be equal to 1. And then we're also going to detach. This function is just basically to say that we don't want this to be a tensor array anymore, and we want it to be a NumPy array. So we're going to convert this to NumPy. And let me search for this because that is not correct. So last input hidden bird. Let's see. Hidden states. I think it's last hidden state, but not sure. Yeah. So here it says last hidden state. Oh, there's actually an example over here. Let's see. Where is it? Here we go. Last hidden state. So let me go and copy paste this. Paste it into last hidden state. Nice. And then after that, we just want to return, well, our embedding to use in our model. Good. So always remember that if you have any questions or something that you want to know, you can just pop it in the chat. I will upload this to GitHub right now, but we just basically created our embedding function. We imported all of the necessary dependencies, and we also formatted our string URI. We created our tokenizer and our model using BERT, which is a model from Hugging Face. So let me type in here, created embedding model. Well, no, it is not embedding model. Embedding return function. Nice. Okay. So now that we have that, we're going to go ahead and actually make our information that we have from our formulary, and we are going to upload those responses into MongoDB. So to do that, we of course want to generate them once I already clicked the button for submitting. So I will change the title of this button and call it submit. And now I will delete this, and I will basically going to generate my document to then convert it into embeddings using my function. So to do that, we want to create our responses dictionary, and in here we're basically going to add like all of the parameters that we have. So we have name, and which is basically equal to name, and then we have what else? Well, let's actually create those variables. So we have name. We also have programming language. Then we have a framework. Nice. So what I'm basically doing here is that I'm just creating like variables for each of our formulary elements. I'm going to call this open source. And then I also have like text celebrity. And finally, I have code editor. Oh, I always confuse. Nice. So now we can actually refer to this in our key value paired elements. So we have name, programming language. So the way that you type in these elements will be basically how they are like uploaded into Mongo. So if you type in like in a different way, the element that is like inside the double quotes will be the element that will be uploaded into MongoDB. Wait a second. Yep, framework. Actually, for these tasks, I usually use Copilot because, you know, why do we need to be typing things that just like are like kind of repetitive tasks, you know? That is like the good side of having like an AI tool in your code editor. Conference blog. Then we have open source. Wait. What else did we have? Yeah, we have text celebrity. Finally, we have code editor. Nice. So we are done by creating our document, and now what we're going to do is that we have to concatenate like all of our responses from our form, because if you remember, in our formulary we basically have them like in different input fields, as we have them like over here. So we have different input fields, and what we want to do is we want to break them down like into different elements. So to do that, we're going to create a variable called concatenated responses. And what we're going to do that is that we're going to leave an empty space after we join them, and we're going to use the join function. And then after that, we want to pass on the responses dot values. Why? Because the values are basically this. So we have the key and we have the value. So I want to pass on just the values. Nice. So we already have our concatenated responses. And what is next is to basically pass on the responses to my embedding model. So to do that, we're going to call the function that we created earlier, and we are going to call this variable embeddings. So this will be called embeddings, and we're going to use the function generate embeddings. And in here, we're going to basically pass on the concatenated responses. Nice. So by this point, our script is basically converting all of our responses into embeddings. And embeddings are basically like the numerical representation of information. So let's go ahead and refresh our Streamlit. And we actually have 10 more minutes. But as I said before, this is a two-part stream. So we will be back. I will be back in like 1 hour. Good. So yeah, let's actually try to output the embeddings so you can see how they are represented like as values. So let's go ahead and do st.write, and we will be typing embeddings. Nice. So let's go ahead and fill this information. So my name is Jocelyn. Right now I'll probably say Python, yeah. I'm not a huge fan, but probably Flutter. Tech conference or blog post. Ooh, Medium is my favorite blog post. Yes, in G Research, which is basically part of the MLH Fellowship. For some of you who are watching the stream and want to apply to the MLH Fellowship, you can also ask me questions, as I am a previous fellow of the program. Favorite tech celebrity? Ryan Swift. Yeah. Favorite code editor? You already saw it is Visual Studio Code. Nice. So let's go ahead and let's wait till it ends loading and click on submit. And let's see. It is taking a while. List object has no attribute size. Let's go ahead and see what's wrong. List attribute. Where did I use the list attribute? Last hidden state, input section, output last hidden state, mean dimension 1. Let's see. I think it probably has to do something with this. Let's see. List object, where is line 64? So let's go and see embeddings generated. Oh, it's probably because it's trying to write this. Let me delete this and see if that is the case. Oh no, why did I refresh? Now I have to type everything again. Oh, that's not good. So for the second part, let's see if we can get this working before the stream ends. So I will just type random things. Favorite framework, Flutter, tech conference, Medium, yes, G Research, Ryan, then favorite code editor, VS Code. Done. Let's click on submit and see what is wrong. List object. Why is it saying that the line 64 has something? Generate embeddings. Concatenate responses. So let me upload this to GitHub in case you want to see. Generate embeddings. And I'm running out of time, and we actually have another stream after this one, so I shouldn't be taking up the whole hour. But as I was mentioning, this is a 2-part stream. So right now, we are having a mini event in like 5 minutes on Discord. And after that mini event, I will be hosting the second part of this stream that will be going on in exactly 1 hour. So in case you want to see how this ends and like actually like end the application that we are building, you definitely want to join the second part, as we will be uploading this information into MongoDB. If you can see right now, we haven't uploaded any information. Like, we just created our responses document and we generated the embeddings, but we haven't uploaded them to Mongo. And if we go back to our cluster, we're basically seeing that the responses are empty because no information has been added. So on the next section of the stream, we will be basically doing that. We will be uploading our information into MongoDB, and we will be able to visualize it as like the regular information and also as the embedding model. And after that, once the user like actually fills out the form, and when they click on submit, it will give you like the top 3 recommendations of persons that you want to talk to in case like you got a high score on your embedding score. Yep. And once we do that, we will be able to plot like the relations in between persons to see like how far away you are related to perhaps me or perhaps someone else that is on the stream right now. And after doing that, we will be deploying our application into the Streamlit cloud, so you actually get the chance to share your application with friends, and you can compare like your scores after they fill out like the formulary about how techy are they. Good. So we are closing up this technical stream, but as I was saying, I will see everyone in an hour for the second part. And remember that if you have any questions or you want to add on something, if you like this stream or you want to improve something or you want to see something additional, we are still on time to receive recommendations for the second part of the stream, which will be hosted in an hour. So maybe if you want to do something specific or you want me to explain something additional or do like another feature, you can pop it in the chat and I will look into it and try to include it on the stream that we have in an hour. Yes, thank you everyone for assisting. I know it might be late for some of you, and yeah, so basically thank you for joining. That is a surprise. We can never say. Swag drops are basically random. So depending on which streams you join, it will be totally random. And remember that just by checking in into the stream, you are receiving points for your global Hack Week score. And if you obtain certain points, then you will be able to obtain swag. Thank you. Bye.